Good morning, guys. So today we will be dealing with a new topic itself, right? And this is the last topic from the theory section. Okay. Now, after this section, the theory entirely is completed, and after the theory is being completed, we will do lots of problems, right? So in the video class we got a little bit idea how an object when falls, what and all will be the equations applied, how it is to be dealt with, right? Now the today's topic is a new one which you have actually, I don't think you guys have learned it before. It is a relative velocity. It is actually not just a velocity. There is relative displacement, there is relative acceleration, right? So the term which in your textbook majorly deals with is relative velocity. Relative velocity means you are going to compare your own velocity or velocity of one object is compared or related with the velocity of another object, right? Some introduction part of this thing which you have, I'm just telling you, has been taught in your first video class, I believe, right? So what do you mean by comparing the two velocities or velocities of two objects, right? See, you know that motion, right? Motion is a relative term, right? Relative term means, see, suppose this is you, right? You are standing on a ground, right? And you saw a car or a bus whatsoever, any vehicle, let's say it's a car, right? And inside the car there are two guys, right? Let's say this guy is A and this is B and you are C, right? Let's say the car is moving in this direction with the velocity v meter per second, right? So for you, that is for C, both A and B, right, are moving in this direction, right? Let's say this is backward direction and this is forward direction. This is forward, this is backward. So for you or in your perspective, this car is moving in a backward direction. Clear? Right? Simple. But if you are having considering only two guys, A and B, right? For A, B is stationary, right? For him, the partner with whom he is sitting is stationary. He is not at all moving. As well as for B also, A is stationary. Clear? So this is different. Perspective is changing. For C, A is moving, but for B, A is not moving, right? So motion is a relative term, right? So we are always telling whether an object is moving or not by comparing with another object, or I can say if with respect to an observer, right, we say whether an object is moving or not, right? This is where the word or the statement or a section I told you, which is known as frame of reference. I've told you before, frame of reference come about. What is frame of reference? The place where the observer is residing, right? This is me, right? Our C, right? Where is this person residing? On the ground, right? So this section is known as, that is this ground on which I am standing becomes the frame of reference. That is with respect to ground, right? A is as well as B is moving in this direction. Clear? Right, this becomes a frame of reference, which ground, right? So the place where the observer is residing, that becomes the frame of reference. This much is clear, right? We have to make this section very thorough, guys, right? Now formula, how we are going for the formula section, right? Let's say there is a section here, there is a person A is residing, there is a section here B is residing, right? Let's say A is moving with a 10 meter per second velocity, right? And this is the first scenario, right? So with respect to B, right, and that is the B is the person who is going to look at A, right? So velocity of A with respect to B, that's how you say, right? With respect to A, what is the velocity of A? So velocity of A with respect to B, I will write it as like this, right? BAB, velocity of A with respect to B, right? That is written by VA minus VB, right? This is how the formula is, VA minus VB. Clear? So what is VA? right? VA is moving in this direction. Let's say this is forward, right? So forward direction, let's say it is positive, right? So it is 10 meter per second, right? In perspective of B, right? The B is the person who is looking at him, right? So for him, I will assume this B is now stationary, right? This B is stationary, right? I have not given any velocity for B. So B's velocity is 0. So what is VAB? It is 10 meter per second. Clear? Right. Now see this, I'm just starting, guys, right? I'm just starting with the basic. Now the previous case itself, we are going to change the scenario. So here we had A, right? Now B jumps over the same plane, and this is B and this is A, and this entire trolley, let's say, is moving with the velocity 10 meter per second, right? So for B, A is not moving, right? With respect to B, A is not moving. Similarly, with respect to A, B is also not moving, right? So if I go for VAB, right, that is with respect to B, what is the velocity of A? So for B, A is not moving means here I can write VA minus VB just like the previous case, right? So velocity of A is 10 meter per second, right? Because it's on the trolley, right? And B is also on the trolley, so it is also 10 meter per second. So what is the net velocity? 0 meter per second, right? 10 minus 10. So with respect to B, A is not moving. So with respect to B, A is not moving has been represented by this equation, right? It is moving with velocity 0 meter per second, right? Clear? That is the meaning of it. Clear? Now the same way we can say for acceleration also. Say if A had an acceleration, say the acceleration is 1 meter per second square, right? Then B will see A, right? And with respect to B, A will be having an acceleration. If I am supposed to write, I will write it like this, that is AA minus AB, right? This is for the first case where the B was stationary, okay? And this was the position of A, like this, right? So what is the acceleration of A? It is 1 meter per second square, and B is stationary means its acceleration is 0. So the net AAB, that is acceleration of A with respect to B, will be 1 meter per second square. That is, B will feel that A is having acceleration in forward direction, right? Clear? Right, these are all the scenarios, guys. Sorry. So let's move on. Right, now suppose the different condition I am taking. This is B and this is A, right? And A is moving, let's say, with the 10 meter per second in this direction, and B is moving with velocity 20 meter per second, right? Now when B observes A, right, when B observes A, speed of A as seen by E, or when, see, simply just think that you are B and you are having a person A in front of you, and he is moving with 10 meter per second in forward direction like this, right? So how would I write the equation? It is VAB, that is velocity of A with respect to U or with respect to B, is equal to VA minus VB, right? So actually each velocity what I am comparing is with ground, right? What is VA actually? It is velocity of A. What is this 10 meter per second with respect to ground, right? With respect to ground it is 10 meter per second. So actually I can write it as VAG, and VB is again velocity of B with respect to ground, so I can write it as VBG, right? So what is velocity of A with respect to ground? It is 10. And what is VBG? It is 20, right? So I'll get minus 10 meter per second, right? Now in Langman language, what does this negative mean? Significant, right? What does it signify? That is when B is following A, right? When the B is following, that is you are following a person A, you will feel that A is what? Coming towards you, right? You are having higher speed, right? You're trying to catch A, right? So A is having lower speed, right? 10 is less than 20, so you can easily catch him, right? So when you're moving at a high velocity of 20 meter per second, you will feel that this person who is sitting in the front of you or running in front of you is coming towards you, right? if I take this forward direction, this one as positive, then this direction will be negative. So how I am feeling that netly that I am moving in 20 meter per second, the first person who was before you is moving with 10 meter per second. Right, since my velocity is higher, I feel that the first person or the person who is in the front appears to be moving in this direction towards you. So this direction positive means this direction will be negative. That is the negative sign's significance. Clear? That is the meaning of it, right? With respect to B, A appears to be moving in this direction. That is the meaning of this negative sign. Clear? Right. Now, let's say that now A is turning and he is saying B. Right. That means the same scenario. See, this is our A. Right. This is our B. Right. So A was moving in 10 and this was in 20. Right. So I can say that with respect to B, B will feel that since he is having higher velocity, A appears to be moving towards him. Right. Now what will be the feeling of A? A will be feeling that B is coming near to him, right? He's saying, oh, he just turned and looked back. He felt that, oh my God, B is going to catch me, right? So B is appearing to be moving in his own direction and it is going on reducing. That the speed is appeared to be increasing in his direction. So VBA, that is velocity of B with respect to A, will be equal to what? VB minus VA. And what is velocity of B with respect to ground, right? So it is with respect to ground. Similarly, of A with respect to ground, that is equal to, what is VBG? It is 20. This is 10. That is 10 meter per second. See, positive way. That is with respect to A, B appears to be much closer. It appears to be coming in this direction. So I just told you this is positive direction. Clear? Right? Clear? I hope this much is clear. Now this is a twisted condition, right? You have to take a lot of directions, etc. Right? That is, you have to feel how it is moving, etc. So I can give you a very this is a twisted thing. So I can go with a shorter trick for solving this much twisted thing. I need not go for it, right? So we'll go for a short trick. So short trick, right? Right, in the first case, let's say B is saying A, right? So we have to make B as a reference, right? So this is our B, this is our A, right? Now we'll take B as reference, right? This was in 10 meter per second, this was 20 meter per second, right? So let us make B as a reference means initially I used to take the velocity of B with respect to ground, similarly velocity of A with respect to ground, right? So now I am going to do is going to take B as reference means I am going to make velocity of B into 0, right? So into 0 means how this is a vector, right? So if this is a velocity 20 meter per second in this direction, right? So I am going to give a minus 20 meter per second. So this direction to B, right? Take this entire system, guys. Consider this as an entire system. I'm just giving a short trick. So if I am adding 20 in this direction for B, then just like a system. So in order to balance, I have to add 20 meter per second in the condition of A also, right? Clear? So with respect to AC, in scenario of A is having 10 meter per second in this direction and 20 in this direction. What will be the net velocity of A then? It will be in this direction 10. 20 minus 10 and 20 is larger, so the same direction, right? So I just told you this direction is positive, then this direction will be negative. So the answer is minus 10 meter per second. That is V what? A, B. It is with respect to B, A's velocity, right? We can take for the same condition, or we can consider the same thing for, or we can do this for same method for VBA also, right? Let's rub it something. right? VBA means which is the reference point I'm going to consider. I'm going to consider the reference point as A, right? So I want to make A into 0, right? So velocity of A has to be made 0 means I have to put 10 meter per second in this direction so that the A will be having velocity 0. Then this will be the direction of what? B also have to add a 10 meter per second in this direction, right? So that A's now velocity has become 0, whereas the B's velocity, net velocity, will be in this direction, right? Because 20 is larger, so 20 minus 10 will be 10 meter per second. So this direction is positive. So VBA will have 10 meter per second, whereas VAB will be minus 10 meter per second, right? First time hearing, it will be looking very odd, but as you listen to the video again and again, it is much more easier, right? Clear? Now again, I can even give you a much more trickier or easiest thing also, but before that we'll go with a smaller section. Suppose this is a train, let's say it is B, and there is another train A, right? Now B is moving in this direction 10 meter per second, right? And A is moving with 30 meter per second. And you are asked what is VBA, that is what is the velocity of B with respect to A. So what would I do? I will make this into 0 by putting 30 meter per second in this direction. So if I am putting in this direction 30 meter per second means 30 meter per second should be at in B also. So what is VBA? Is 10 plus 30, both are in the same direction, right? It is 30 meter, sorry 40, right? Sorry, I made a mistake of adding. It becomes what? 40 meter per second, right? In which direction? In this direction, that is positive. Clear? Easy, right? We did it in a very simple method, right? Similarly, if it is VAB, right? So that means I have to A with respect to B. So how can I find? B has to be nullified into 0, right? So what would I do? I will put in this direction 10 meter per second. So B becomes 0. So what will be the velocity of A? It will be in place, this 10 meter per second has to be also put here. So it will be 10 here. So this 10 and this 30, right? So it is minus 40. Why? The direction is like this. So it is minus 40 meter per second. Clear? Right? Simple. Now let's move on with another short trick. This is the final short trick and the most easiest one if you want to avoid picture drawing, etc. Suppose there are two bodies again, A and B, right? And they are moving in same direction. Then VAB, I will write it as VA minus VB, just like the previous case. That means when both objects are moving in same direction, so always find minus, subtract that. If there are two objects A and B and they are moving in opposite direction like this, then the relative velocity between them is sum of them, VA plus VB. Right, net direction cannot be known by this simple, but I am just giving you a proper answer. If both objects are moving in same direction, the net velocity is difference of them. If both of them are in opposite direction, then the net relative velocity is sum of them. Clear? Right? So I could have given the direction or equation straight away itself, but I believe that you guys have to understand the logic of it, then only go for the tricks. Clear? Right. Now let's move on again. So there is a trolley like this, right? A person is standing over here. Let's say that person is A, right? Another person B is standing on the ground, right? So let's say make them as B has been repeatedly used. Let's make him P, right? Right, this is a trolley. Let's say this person is moving on the trolley, right? Is moving on the trolley with a velocity 2 meter per second. So that is this person A is moving with respect to T. So I will write it as VAT, that is 2 meter per second. Now with respect to ground, the trolley is moving, right? So his velocity is 10 meter per second. Sorry, right? So this much is clear, right? So how and all I can write the equation VAP, right? So if you are asked what is the velocity of A with respect to P, this is how you write, right? So with perspective of P, what is the velocity of A? So I will write just like I will go for the formula straight away. I will write VA minus VP, right? So always you write the velocity with respect to ground. So it is VAG minus VPG, right? So what is the velocity of P with respect to ground? He is stationary, so it is 0, right? So VAP is equal to just VAG, right? Simple. Now, okay, let's move here, right? So how can I rearrange it? How can I find VAG? As per this figure, I don't know the value of VAG. So what is VAG? VAG is what is the velocity of A with respect to ground. So again I will write it as what? I cannot find the value, or I cannot write this as a subtract quantity, right? So I will use another formula section. I don't know why it is not going. Okay. Right. How can I find VAG? So what is VAT? That is velocity of A minus velocity of trolley. Or we have to write it as VAG minus VTG. That is with respect to ground we are writing every person's or each material's with velocity. So what is VAG? I don't know. That is what I have to find. What is VAT? I have just written it as 2 meter per second. Right? Minus what is trolley's velocity with respect to ground? That is 10 meter per second. So I can easily find VAG is, right, it is 12 meter per second. Easy. Now found the value of VAG. So what is velocity AP? That is velocity of A with respect to P is 12 meter per second, because it is the value having the same as that of VAG. Simple. That is with respect to P, A is moving with the velocity 12 meter per second. In which direction? In this direction. Forward direction. Simple. Right. Now let's do another section. Similar type of problem itself. Let's say this is a car. Right. And the car is moving with the velocity 20 meter per second. There is a person here. Right, he is trying or using a wheel, okay, and he's driving, right, and there is a trolley here, right, and the trolley is having a person, right, and that person, let's say, is moving 3 meter per second with respect to the trolley, and the trolley is moving in this direction with 10 meter per second. So this 3 meter per second is let's say the person is A, right, so it is VAT, right, this is VTG, that is trolley's velocity with respect to ground. This much clear? And same I am going to ask you, what is VAP? That is velocity of A with respect to P, velocity of this person with respect to this person, right? So similarly, what is VAP? It is VA minus VP, right? So what is VA? Velocity of A with respect to ground, right, minus velocity of P with respect to ground. Now what is velocity of P with respect to ground? This is our ground. P, the car is moving with 20 meter per second, means you or the P person is also moving with 20 meter per second. So I can write it as VAG minus 20. That is our VAP. Right. So in order to find VAP, I require the value of VAG. So just like the previous case, how can I find VAG? VAT. That is equal to VAG minus VTG. Now what is VAG? I don't know. Or velocity of A with respect to ground, I don't know. What is trolley's velocity with respect to ground? It is 10 meter per second. And what else? Velocity of A with respect to trolley. Which direction our A is moving? VAT. A is moving in this direction. I told you this direction I am going to take positive, forward direction. Then this direction is negative. So VAT is minus 3. That is equal to, what do you write it as? VAG? VAG minus 10. So you will get VAG as plus 7, right? It is 7 meter per second. Right, so I write here 7 minus 20, that is minus 14 is the meter per second is the velocity of A with respect to P. That is, if I draw the significance, that is a person P inside the car will feel that A is moving with a velocity, how much? 14 meter per second, right? Towards himself. Yeah, this is something which is simple, see, right? You are in a car, it is having higher velocity, the trolley is having lesser velocity, means you will feel the trolley is moving towards you. Clear? Simple, right? We'll go with the common type of question which is asked with this is how a police catches a thief. This is our thief, this is our police. Initially they are at 100-meter distance. Thief is moving with 10 meter per second. If the police has to catch, means it has to have higher velocity, let's say 20 meter per second. So what is the time by which police catches thief? Let's say this is the scenario, the police has caught the thief, okay, right? Let's say T is the time by which, that is, say 10 o'clock, both of them started from this point. At 10:05 they reached here, that both of them are reaching the same point at the same time itself, but they have to cover different distances. P has to cover larger distance, whereas T has to cover less distance to reach this point. As per the diagram itself, it is understood, right? So in 5 minutes, let's say 5 minutes, right? 10:05 here, 5 minutes, how much is the distance the P has to travel? It will be 20 into 5. 20 is the velocity, 5 is its time, right? Whereas in 5 minutes T has to travel how much? 10 into 5, 50 meter only. This has 100 meter. And who has to cover larger distance? Police has to cover largest distance. The thief has to cover only small distance. I hope you understood. But they reached the same point, because this point is at a distance of 100 meter from P, whereas it is at a distance of 50 meter from thief, closer to the thief. I hope you understood. Now we are going to the problem side itself. Right, now I just told you 5 minutes, right? Now we don't know the time, right? So let's say by T time interval, P has caught T, right? So P will be covering how much distance? T into its velocity, which is 20T, whereas thief will cover only 10T distance, right? Now that means this is our police, this is our thief, both are caught like this, right? So this was 100 meter, right? So from police to this point is 20T, from thief to this point is 10T, right? So from the figure, can't I write 20T is equal to 100 plus 10T, right? So from solving this equation, I will get T is equal to 10 seconds. That is, within 10 seconds, the police is catching the thief. Simple, right? Now then another type question which is asked is, how much or at what distance the thief is catching him, or how much distance the point, this point, right? This point is at a distance 10T, means 10 into 10 is 100 meter from the thief, whereas this point is at a 20T, that is 200 meter, right? T in place of T I have to write 10 seconds, right? So from police, the catching point is at a distance 200 meter, right, from police. From thief, the catching point is just at a distance of 100 meter. Clear? Right. Now this is a lengthier process. Now I can just give you a small trick. Right. Suppose if you are asked what is the time, you know time is distance by velocity, right? Whatever be the condition, right, if you are having two, relative displacement between 2 points is always constant, right? This is our police, this is our thief. The relative distance between them was 100 meter. That 100 meter always remains constant. Why? If this person is moving, means this person is also moving in this direction, right? So with respect to displacement, it is irrespective of the frame. It only depends upon these two guys, not on any observer, right? If I am looking at from home, the displacement will be 100. If I look from moon, then also the displacement between those two guys is 100 meter. So in place of this displacement, or the distance, I would write relative distance, and then relative velocity. Right, this is a short trick, guys. So if you are asked what is the time at which they will be caught or the thief will be caught, means I can just write relative distance between police and thief, which is 100 meter. What is the relative velocity? I just told you when both of the objects are moving in same direction, I will minus the velocity. That is 20 minus 10, that is 100 by 10, that is 10 meter per second. That is the shortest trick. Right, so what is time in the case of police thief catching? Relative distance by relative velocity. Clear? That is the initial distance between them divided by relative velocity between these two guys. That is the shortest equation. That is something which you have to use during your NEET examinations.